Today, we'll explore the world of AI innovations reshaping technology as we know it. From breakthroughs in ancient mathematical mysteries to new methods for streamlining AI deployment and fostering transparency in model usage, we're diving deep into the latest developments. This episode is packed with insights, perfect for engineers looking to stay ahead of the curve in AI technology. For nearly 87 years, the Jacobian conjecture has puzzled mathematicians worldwide. This long-standing mathematical enigma, proposed by Ott Heinrich Keller in 1939, suggests that any polynomial map from Strang to Celan with a constant non-zero Jacobian determinant is invertible. In a stunning turn of events, Anthropic's Claude Fable 5 has delivered a counterexample to this conjecture, redefining possibilities in mathematical research and the role of artificial intelligence in scientific discovery. Guided by mathematician Levent Alpoj, Claude Fable 5 generated a specific polynomial map from setting to set C, demonstrating a constant Jacobian determinant of -2, yet crucially, it remains non-invertible. This result fundamentally disproves the conjecture, showing that polynomial maps retaining this property do not necessarily imply invertibility. Delving into the technical specifics, Claude Fable 5 constructs this map by and meticulously ensures it maintains a consistent Jacobian determinant across all instances, an accomplishment central to this groundbreaking discovery. Such intricate polynomial structures typically involve analyzing degrees and coefficients that challenge even seasoned mathematicians. The AI was programmed to explore myriad configurations, isolating those that would yield the desired non-invertibility while maintaining the constant Jacobian, a task of considerable computational intensity. From a numerical perspective, achieving a Jacobian determinant of -2 within subtube space set a significant benchmark. The counterexample generated garnered rapid attention and was vetted by a peer group of mathematicians within just 24 hours, showcasing the potent collaborative dynamics between AI tools and human expertise. However, the breakthrough raises notable questions and challenges. Peer validation is still ongoing, requiring extensive scrutiny to ensure mathematical integrity and universal acceptance. Furthermore, there remains uncertainty whether AI-driven approaches like Claude Fable 5 can be effectively generalized to tackle other complex conjectures. Such reliance on AI brings concerns regarding human interpretation and ethical considerations in applying machine-generated proofs. For those intrigued by this development, a deep dive into Claude Fable 5's documentation stands as a valuable exercise. Moreover, reviewing the counterexample on platforms such as Arxiv can offer further educational insights into AI's potential in mathematical explorations. In essence, AI's success in addressing the Jacobian conjecture not only marks a significant step in computational mathematics, but also signals a new era of synergistic advancement where AI augments human capability, potentially unlocking solutions to challenges previously deemed insurmountable. This development invites a reconsideration of AI's role in scientific research, with implications reaching beyond mathematics and into diverse fields of inquiry. Amazon Bedrock's integration of OpenAI's GPT 5.6 models, Sol, Terra, and Luna, marks a significant advancement in AI capabilities for enterprises, geared towards improving efficiency and performance in AI workloads. After an initial preview period, these models are broadly available, primarily enhancing tasks that involve autonomous coding and reasoning. The flagship model, Sol, is a standout, boasting a 54% increase in token efficiency for coding tasks compared to its predecessors, making it a choice tool for enterprises aiming to optimize their AI operations. From a technical perspective, these models, when integrated into Amazon Bedrock, enable scalable and secure AI application development. They are tailored to specific workloads: Sol for high-efficiency tasks, Terra for balanced applications, and Luna for speed-centric needs. A robust security feature is the hardware-enforced measures that ensure zero operator access during inference, thereby fortifying the models against unauthorized access and ensuring compliance with security protocols. Regarding performance metrics, the Sol model's 54% improvement in token efficiency is crucial for tasks that require extensive data manipulation, such as large-scale software development or data analysis. The introduction of a caching mechanism can lower the operational costs significantly. For example, Companies can achieve up to a 90% discount on repeated input costs by leveraging prompt caching, which efficiently manages repeated queries and operations, cutting down on redundant computational expenses. Access, however, is a nuanced aspect. Initially restricted to around 20 government approved entities due to cybersecurity concerns, the access limitations might impede wider adoption and innovation. These constraints highlight the growing influence of governmental oversight in the deployment of advanced AI technologies. For developers and enterprises keen to utilize these models, Amazon Bedrock provides a seamless platform. Accessing these models starts with consulting AWS documentation to understand the deployment process. The documentation provides detailed insights and code samples, enabling practical trials and simplifying the adoption process. Overall, the introduction of the GPT 5.6 series on Amazon Bedrock offers a revolutionary stride for enterprises looking to advance their AI capabilities. These models bring a combination of enhanced performance and security, positioning themselves as valuable tools in the evolving landscape of AI technologies. However, the regulatory and access challenges present areas that organizations must navigate carefully to fully capitalize on these advancements. NVIDIA's ModelExpress (MX) is setting the stage for faster AI deployments by revolutionizing the distribution of model weights across computing clusters. As businesses shift towards more scalable AI solutions, MX plays a critical role, especially for users of NVIDIA's Dynamo platform. This system is designed to minimize time delays, which can be a bottleneck in large-scale AI implementations. At the heart of ModelExpress lies the capability for peer-to-peer distribution of model weights, utilizing high-speed networks such as NIXL and RDMA. These networks are renowned for their low latency and high throughput, crucial factors when initializing AI models at scale. With MX, a worker within a cluster can seamlessly publish the availability of model weights, allowing other workers to quickly access and download the necessary data. This method is a stark contrast to traditional approaches, where each worker had to download the entire model from a centralized storage system, often leading to significant latency and resource congestion. While NVIDIA has not yet disclosed specific performance metrics, the anticipated improvements in startup times are expected to be substantial. This is particularly important in Kubernetes environments, where rapid scaling and responsiveness are often required amid fluctuating workloads. Such enhancements could decrease initialization times significantly, thus fostering higher productivity and more efficient resource utilization. However, the deployment of ModelExpress does not come without certain challenges. The system is currently optimized for use within Kubernetes environments, potentially limiting its flexibility across other orchestration platforms. Also, the scalability of MX in environments with high network latency remains an area under investigation, posing a potential hurdle for broader adoption. For developers looking to implement this technology, integrating ModelExpress into existing Dynamo workflows is essential. NVIDIA provides comprehensive documentation to aid in setup, enabling teams to conduct benchmarking tests in their specific environments. Such tests can offer insights into the real-world performance improvements offered by MX, allowing organizations to make informed decisions about its deployment. In summary, NVIDIA's ModelExpress stands to significantly improve the efficiency of AI model deployment, potentially setting new standards for model distribution techniques. As organizations continue to scale their AI operations, embracing such innovations could lead to substantial efficiency gains, reducing costs and enhancing operational speeds. The future evolution of ModelExpress might also inspire similar advances from other companies, particularly in high-performance computing domains, further influencing the landscape of AI technology. Transparency in AI model usage is gaining significant attention as users, organizations, and regulators focus on the ethical and practical implications. As AI services proliferate, particularly those offered as model as a service, transparency is not just a buzzword. It's becoming a crucial metric of trust and compliance. Regulatory frameworks like the EU AI Act and Federal Trade Commission (FTC) guidelines have set the stage for stronger transparency obligations. These regulations require companies to disclose the specific AI models they use, as well as detail their data usage processes. For practitioners in the field, this means APIs must be designed to offer clear pathways and documentation to let users see exactly what models are being employed. Comprehensive documentation of data sources and model limitations is not just recommended, it's becoming a necessity. The Foundation Model Transparency Index, for instance, illustrates that many developers currently fall short in this area. As of October 2023, it was found that a significant number of major AI developers had insufficient transparency measures, revealing a gap between industry practices and regulatory expectations. Furthermore, while such measures intend to build consumer trust, their efficiency is debated. Nearly 70% of AI tool users consider current transparency measures inadequate, indicating potential room for improvement even within regulatory frameworks. The introduction of new guidelines, such as those from the European Commission in July 2026, highlights attempts to unify these practices globally. Organizations must review and update their compliance protocols regularly to align with these evolving standards. Tools like the Foundation Model Transparency Index can be leveraged to monitor vendor practices and ensure they meet these standards. Additionally, requiring vendors to provide specific evidence of model provenance and update processes can aid in maintaining a robust compliance framework. However, achieving this level of transparency presents challenges, particularly the balance between providing sufficient information and protecting proprietary data. As transparency measures increase, so too does the risk of compromising sensitive information, leading to a difficult trade-off. The bottom line is that while greater transparency can foster consumer trust and accountability, it also highlights ongoing tensions between public transparency and the protection of proprietary technologies. Companies navigating this landscape must innovate ethical solutions that balance these competing interests, potentially setting new precedents in AI industry standards and paving the way for broader adoption and trust in AI technologies across sectors. Andrew Ng's release of OpenWorker is reshaping the landscape of AI productivity tools by offering a local-first, privacy-focused AI agent that seamlessly integrates into your workflow. Announced in July 2026, OpenWorker focuses on delivering finished tasks rather than conversational responses. It runs locally on Macs with future support for Windows. By integrating with tools like Slack, OpenWorker enhances productivity while prioritizing data privacy. Here's the technical breakdown. OpenWorker relies on a local-first architecture that retains data on users' devices, ensuring that sensitive information remains secure and accessible only to the user. This architectural choice prevents data exposure and offers a consistent environment for AI-driven tasks without the variabilities of cloud dependencies. Integration with popular communication and organizational tools like Slack, email, and calendar apps allows OpenWorker to act as a proactive assistant that seamlessly merges into existing workflows. For instance, it can automatically update your calendar or draft a polished document using AI model outputs without requiring manual intervention, thereby expediting routine tasks. OpenWorker supports multiple AI models, such as GPT 5.6 and Gemini 3.6, allowing users the flexibility to choose models according to their task requirements. This configurability is achieved through an API key system, where users input their credentials, enabling OpenWorker to harness a wide array of AI technologies. The user experience greatly benefits from these local-first operations, offering vastly reduced latency compared to traditional AI models reliant on cloud processing. The performance payoffs, though exact figures are not detailed, suggest notable improvements in speed and efficiency regarding task completion. However, the requirement for users to manually configure their chosen AI models could pose a challenge, particularly for non-technical users. Windows support remains under development, restricting potential adoption among a broader user base and possibly causing frustration for users dependent on this platform. To explore OpenWorker in depth, interested users should visit the official OpenWorker web openworker.com/utmsourceOpenA, where they can find comprehensive documentation, as well as the GitHub repository for access to source code and contribution guidelines. This open-source nature not only allows users to tailor their installations, but also fosters a collaborative environment for developers to contribute and enhance the software. In essence, OpenWorker represents a paradigm shift in AI usability, emphasizing finished deliverables rather than mere conversational interaction. It is particularly relevant for users and organizations that value data privacy and efficient task management over traditional chatbot functionalities, thereby setting a new standard for AI workplace tools. In the evolving landscape of artificial intelligence, the development of agent skills remains a pivotal area of research. Recent findings underscore the indispensable role of human expertise in crafting effective AI agent skills, highlighting how integrating human-curated skills into AI systems substantially enhances their performance capabilities across various domains. A study conducted by Microsoft Research introduced a novel concept called meta skill, designed to optimize the extraction and application of skills. This concept revolutionizes the traditional approach by focusing not just on the volume of skills, but on their intrinsic utility grounded in human insight. The impact is quantifiable and significant. Curated skills improved pass rates by an impressive 16.2 percentage points across 86 tasks and 11 diverse domains, a testament to the advantages of human oversight. The research suggests that integrating human expertise involves detailed task-specific skill design, emphasizing the precision of skills rather than the scale. This requires encoding procedures closely tied to real-world utility, ensuring skills are not only relevant but highly effective. The contrast between curated and AI-generated skills is stark. Self-generated skills often result in flat performances, with little to no improvement when compared to a no-skill baseline, highlighting their limited practical benefit. Although model-generated skills theoretically offer procedural enhancements, the realization of their potential is fraught with challenges. AI's ability to generate skills independently might fall short in areas necessitating nuanced understanding and tailored solutions. The traditional AI model approach may exhibit strong capacity for skill extraction, yet falter as consumers of such skills, or vice versa, demonstrating the complexity of the skill extraction consumption dynamic within AI agents. Another pivotal aspect is the skill bench benchmark, a significant tool in evaluating the efficacy of curated versus self-generated skills. By benchmarking performance across varied tasks, SkillBench provides a utility-grounded framework for assessing how these skills translate into practical outcomes. However, the research landscape is not without its uncertainties and trade-offs. While human-curated skills demonstrate clear advantages, their scalability and adaptability as fields evolve pose ongoing challenges. The potential for AI agents to autonomously hone their skills remains an open question, demanding further exploration. The long-term effectiveness and sustainability of human-intervened skill development in rapidly shifting environments remains speculative. For AI developers and strategists, engaging with the SkillsBench benchmark on the HyperAI platform offers valuable insights into identifying gaps and formulating effective skill strategies. Additionally, exploring the detailed meta-skill methodologies outlined in the Microsoft Research publication can provide actionable guidance on optimizing skill development practices. In conclusion, the takeaway is clear. Human expertise continues to play a crucial role in AI skill development, providing significant enhancements in AI effectiveness. While the challenge of scalability persists, the ongoing integration of human-centered approaches seems essential for advancing AI capabilities. As AI technology surges forward, reevaluating the interplay between automated and human-curated skills will be crucial to harnessing its full potential. The Drawing Arena experiment showcased a compelling intersection of technology and art, tasking several advanced AI models with the creative challenge of replicating the iconic Mona Lisa using colored pencils. This innovative approach allowed researchers to assess not just the technical capabilities of AI, but also their potential in creative fields. Among the participants, GPT 5.6 Sol stood out considerably by demonstrating both cost-effectiveness and efficiency. It managed to produce 7 drawings at a minimal cost of $7.74, showcasing its ability to generate detailed artwork without exorbitant expenses. In stark contrast, Claude Fable 5 was significantly less efficient, requiring approximately $160 for outputs that did not match GPT 5.6 Sol's quality. The technical aspect of this experiment revolved around a colored pencil toolset, assessing the ability of AI models to mimic intricate details of classic artworks. It evaluated models based on cost, accuracy, and speed, highlighting the limitations and strengths of their underlying machine learning architectures. For instance, Grok 4.5, while taking an average of 99 steps per drawing, utilized cached reads to maintain cost effectiveness, proving that efficiency isn't solely dependent on rapid execution, but also on smart resource management. Despite these promising outcomes, the research reveals significant performance gaps that question the scalability of AI in handling more complex artistic tasks. There is an implicit suggestion that advanced training methodologies are necessary to improve these capabilities further. The implications for developers and businesses are profound. Models like GPT 5.6 Sol, which balance cost and performance, are increasingly attractive for budget-conscious applications. Understanding these performance metrics can steer future training strategies and model selection processes. The drawing arena not only illuminates the current capabilities of AI models, but also sets the stage for future explorations into AI-driven creativity. Interested parties are encouraged to explore the detailed results available on the TryAI blog and even attempt their own experiments with the provided colored pencil toolset. Such first-hand exploration could provide deeper insights into how AI can be integrated into creative processes and perhaps lead to innovations in artistic fields. Ultimately, this experiment challenges conventional notions of creativity, proposing intriguing questions about the role AI might play in the evolution of art. As AI continues to evolve, its potential in recreating and perhaps even originating art remains an area ripe for exploration and development. The introduction of the cost per successful task (CPST) metric marks a significant shift in how AI model efficiency is evaluated, moving beyond the traditional dollars token metric. This innovative approach accounts for the total financial expenditure associated with task execution, including retries and tool usage. Such a comprehensive overview highlights the true cost of deploying AI models, offering a more insightful look at economic performance. The CPST metric is particularly revealing when examining models like DeepSeek v4, which led across 7 out of 12 task families, despite achieving a lower general pass rate. This suggests that simple pass-fail metrics do not adequately capture model efficiency, as CPST considers nuances like the cost of repeat attempts and tool integration that can inflate expenses despite apparent effectiveness in narrower contexts. The benchmark study evaluated 720 browser automation tasks, essential for assessing structured output reliability and inference latency. This approach provided diverse data inputs to gauge how different models manage task efficiency and cost. The findings showed less than 50% alignment between CPST and traditional token estimates, advocating for broader adoption and encouraging organizations to integrate this metric comprehensively into their AI evaluation processes. Transitioning to CPST has direct implications for procurement strategies. As projections indicate, 85% of AI procurement requests for proposals, RFPs, will incorporate CPST by Q3 2026, signifying an industry-wide shift. This metric forces companies to reconsider their billing models, moving towards usage-based systems. Although more reflective of actual costs, this shift can complicate budgeting, especially for large organizations. It necessitates adopting new financial planning tools and strategies to accommodate fluctuating costs that depend directly on AI usage rather than flat rates. Practically, organizations interested in leveraging CPST can start by evaluating their AI models using this metric with established formulas from providers like Digital Applied. This involves analyzing how retries and tool usage impact overall economic performance, thus enabling more informed decisions in model selection and deployment. CPST not only reshapes how AI's financial assessments are conducted, but also encourages a deeper dive into understanding related costs and impacts. This can drive innovation, urging developers to prioritize cost-effectiveness alongside performance, potentially influencing pricing strategies across AI service providers. Moreover, as AI model subsidies conclude, the necessity for accurate cost tracking becomes paramount. further cementing CPST's relevance in modern AI economics. LlamaParse's recent update for the N8N platform marks a transformative step in automating document workflows through its enhancements in versions 5 and 6, promising to streamline processes across varied use cases. Released on June 25, 2026, version 5 of the LlamaParse platform node introduced a foundational rewrite, pivoting from reliance on an SDK to employing direct HTTP calls. This shift not only reduces dependency on intermediary software layers, but also optimizes the system's overall efficiency. By improving binary file handling, version 5 is particularly adept at managing complex document formats such as PDFs, which are prevalent in business operations. This enhancement is crucial for organizations dealing with intricate document workflows, ensuring data is processed smoothly without the bottlenecks that might arise in more legacy systems. Version 6, released shortly after on June 30th, 2026, refined this configuration further, consolidating multiple functionalities into a single API credential. This means that instead of managing separate nodes for parsing, classification, extraction, splitting, and retrieval, users can perform all these actions robustly through a unified interface. This integration supports dynamic and context-aware operations within N8N, a popular open-source workflow automation tool known for its accessibility to non-developers. Despite these advancements, LlamaParse has not disclosed specific performance metrics for these updates, which could initially deter some users due to uncertainty. As it's a relatively new release, user adoption metrics and feedback are still emerging. Nevertheless, engineers and developers are encouraged to explore the new functionalities by visiting the official N8N integration page for LlamaParse. Here, they can find comprehensive documentation on implementing the LlamaParse node into existing workflows. By leveraging community tips and shared experiences, users can optimize the integration's effectiveness, potentially addressing any limitations they encounter during deployment. However, the reliance on LlamaParse's API indicates that any downtime or service issues could impact N8N workflows, making it essential for organizations to have contingency plans. In summary, the LlamaParse node significantly enhances document processing within the N8N ecosystem. Its streamlined capabilities offer developers powerful tools to reduce manual input, paving the way for more efficient and automated document management solutions. Yet users should remain vigilant about ongoing updates and community insights to maximize this integration's potential. Today, we've explored the dynamic intersections of AI with mathematics, enterprise technology, artistic endeavors, and practical productivity. The narrative across these segments encapsulates an exciting transformation in how AI reshapes traditional and modern landscapes. Stay curious, keep experimenting, and we'll bring you more insights in the next episode of Daily AI Brief.